All right, so next section is what we call the advanced section. And this is in obviously, sorry, not necessarily any order. It's just as it comes up in the conversation. I just want to make sure that we cross these off and just go with the questioning and also go with where we are in the presentation. So some of the things we want to talk about are the attack of the clones. Preceding we talked about already to some extent. We can revisit that if we need to. And then just some ideas like moving replication from storage controllers to hypervisor. And we could even start with that idea, if you'd like, of some of the feedback we've gotten from real life customers. So if you want to go there, then we'll talk about thick to thin provisioning at the virtualization layer, storage tiering, and then just look at the VRAs themselves, these little guys, and then talk a bit more about cloud. So in whatever order this makes sense to go in, we just want to make sure we hit these points.
So in a sense, we talked about moving replication from the storage controller to the hypervisor. If we take this point in a little bit higher level, I think that we all know of the software-defined data centers, right? It's where things are going, right? Things are going from the hardware to the hypervisor level, where they are more easier to manage and fit where everything is happening today, right? Hypervisor are becoming the full control of the IT environment in these days, whether it's networking, whether it's security, different storage services, and it makes sense basically to put replication in the same layer, right? It makes sense because it gives you exactly the level of granularity and visibility and virtual awareness that you need. So we started Zerto long before software-defined data centers were a term that everyone knew, right? But
you mean before VMware started pounding that into everybody's head? Yeah.
Right.
I remember the good old days.
But to the point, we're kind of leading this. We're leading the replication space with the same trend that we're seeing across the board. And there are many benefits. So obviously we talked about how easy it is to replicate virtual machines instead of LANs, right? We could see how easy it is to set up replication. Every one of you that tried to do something similar with their own storage array vendor of choice know that it's probably days of professional services to get to the same point that we got here. The granularity level of both protection and recovery. You don't have to protect complete LANs. You don't have to organize the whole environment, right? At the same way you want your protection and recovery. It doesn't break because things are moving around, right? And then go figure where this VM is now storage vMotion to and what LAN it resides on. And there's another big benefit, and that's the fact that the whole overhead of replication on the storage controllers is now moving up. And we know that this overhead on the controllers can be pretty expensive, right? We hear from our own customers, and definitely the enterprise type of customers are talking about it quite a bit. Doing replication at the array level requires that you size your arrays properly, right? And you're either snapping or replicating. There are resources that are being taken, and there's costs associated with doing replication at the storage level. We basically take it up to the right place. We have examples of customers that were able to save significantly on the replication just because of the granularity aspects. They don't need now to protect everything just to be sure that they are protected. They can protect exactly what they need. So there's less storage involved in the DR side, and there's less bandwidth involved in order to ship all this data all the time. And there's less processing involved. Right? So we've taken this point and we give you basically exactly what you need at the right layer. Questions so far?
Have you actually cut out the resource, saying it takes less resource? Haven't you just moved it out of the storage array into your hosts? I mean, is there any significant compute impact on ESX hosts for doing this?
So actually no, these VMs that you see here, the VRAs, they are extremely lean VMs. It's by default they are installed with 1 virtual CPU and 2 gig of virtual RAM. That's their default sizing. They are extremely simple. They don't do much. They do the data shipping, obviously in a consistent manner, and they do compression if you have compression enabled on this application. And that's what they do. And they are limited to how much you're willing to give them.
Because compression, I mean, that could use a lot of CPU and a lot of memory.
Right. So one
if
of
you
the
have a
things
lot of bandwidth.
Well, it depends on how good your compression is. I mean, you can do really, really simple, or you can do really complicated. But even if you don't have a lot of bandwidth, I mean, even if you're not shipping that much data, you can spend hours of CPU time trying to wring every last bit out of it.
To that point,
So it's
It's
an excellent
stupid.
Yeah.
So it's an excellent point actually, because we've
Yeah.
done one of the things that you
Yeah, I mean, it's it's basic LZ. It's not.
Okay, is it?
it's more than basic LZ. So to the point, what we've done is, and I know you had a question, I'll come back to it in a second. What we've done is integrated some sophisticated algorithms within the VRA to make sure that we basically control the level of compression that we're doing compared to the level of resources that we have available
Yeah.
to compress.
That's what I was getting at.
Right, so,
Yeah, but
it's not,
remember,
it's not that
also,
we're trying
it's
to
also
fight.
balancing it against latency. You know, it's not just that you can spin infinite CPU, but it would add infinite time. That the whole idea.
This isn't primary storage, so it's better. I mean, it is, but you know what I'm saying.
Yeah.
It's not as latency sensitive.
No,
the
it's not-
if
it's
you
not
have tons of latency, then you just don't get as much data over there. You know.
Yeah, it's not microsecond latency
Yeah.
sensitive, but it is millisecond latency sensitive.
Okay. All
Yeah,
right.
but it's not, to the point, I think that Stephen mentioned, since it's asynchronous replication, your application is not affected by asynchronous replication latency, right? And in any case, the algorithm there is smarter than just trying to spin cycles and try to compress data that is not compressible. What was your question?
Well, I was just going to kind of funnel off of that, is that do they function a lot like the vSphere replication or the replication servers, where if you hit a certain number of machines that you're replicating, you need to deploy another one and another one to balance that load across?
So you can have one VRA per host in Zerto. There's obviously the question of how do we scale it and how do we make sure that there's a certain limit of the number of volumes that a VM can hold in the ASICS environment. So instead of letting you go and spin additional VMs, when we hit a certain threshold of volumes that is protected on a host, we automatically spin another even smaller VM. This one does not even need to have the amount of resources that the VRA have. Another VM that can basically hold the volumes for us and allow us to have quite a big consolidation ratio.
So it's volume based, it's not VM based?
It's, yeah, the factor there is the number of volumes that you can hold on.
Because the VM doing the replication has to see all of the volumes, and there's a
Right.
limit as to how many volumes one VM's allowed to see. So
Right.
if you're saying replicate more than that, they
Right.
need to
Then we
spawn the second
spin.
one.
Then we spin another VM, but we spin it for you, so you don't have to touch it. The system knows
So
when.
it's on, deprovision it, or we'll just keep it out there?
No, it will know exactly if you take VPGs away and we don't need the VM anymore, we'll take it off. It's totally managed. The one thing that we really keep we can't be more aggressive on it than we are, is to keep things simple and as much as possible hands-free. You need to protect what you need to protect and know that it's there. You don't need to go babysit the system all the time and this tons of hours of managing it. That's not the goal.
Yeah,
We
if
can
you,
always.
If you needed to totally babysit it and handhold it all the time, then you could just call it SRDF.
Sure.
Or double take.
Oh. Zing.
Well, you know.
Okay. It's great that these comments doesn't need to come from me.
Yeah.
It's awesome.
Just set it up.
We've done it before.
I've only done 17,000 DR.
I would say as a recently new insider to Zerto, that Hen is definitely the philosopher behind the product. It's not should you do it all the time. Is it the right thing to do? And if it's not based in the core of what we want it to be, which is simple yet powerful under the hood, then I see a lot of requests from different folks in the organization wanting, can we do this? And Hen usually comes back with, yeah, but should we do this? Because it gets out of what the nature we want this product to do. So that's just, I was sitting on this side of the table recently, so I like to share that. Go ahead.
Thanks. I think that the next one we wanted to touch is cloning, right? The offset cloning capability.
Yeah, so we'll do cloning. Because we touched on preceding, so I think we got this one. Do we need to revisit preceding? Everybody here okay with preceding? The fact that you click, 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 there's the VMDK, and it does a delta sync between the two sites. Okay? So if we need to, we can go
Can I
into
do a
it.
physical precede?
Yeah, so what you grab a bunch, you get them to the remote site, however, terabytes, whatever it is, and then when we configured that VPG as he did, he mapped, he mapped into the data store, and we just drill into where that the VMDK is, and it starts the delta sync. You missed that because you were out.
Let me
He'll go back to it, but
let me go back to it pretty quickly.
we can quickly show you.
So
Okay, so I've got a primary site and
Yeah,
a DR site
and you've
and,
dumped your
and
VMDK.
limited bandwidth.
Right, and you've got you
And
take.
so I want to plug a USB hard drive
Yep.
in some place at the primary site,
Mhm.
have you put data on it,
Yep,
FedEx it.
yep.
Okay,
ship it over,
You've dumped
Yep.
it to the data store over here,
dump it to the data store that you want, go and select preceding,
and this is what you do.
map
And-
each volume to its source and target,
And it's
we'll, instead of shipping the whole data,
and you'll resync it.
we'll
Yep.
just be syncing the delta changes from
Right.
the time you dumped it
Yeah.
to the
I think
sitting
the
point.
actual copy is done outside of Zerto though. So when you copy the VMDK to your USB drive or your flash drive or your ST5 or 6 or whatever, that's
Mhm.
done through other processes rather than through
Right,
the Zerto
so,
software.
so it's, the idea is not to use, you can do, obviously the simplest is what I've demoed, right?
Mhm.
Click, 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 done, let Zerto transfer the data. And
Right.
it could be done through Zerto, but if you don't want to wait for the bandwidth or whatever, you would take it in,
So I would
whatever
go back, I would do a
outside
backup
of,
restore.
or
Yeah.
do your backup
Yeah.
restore. Or we have cases where people use Zerto to replace their current DR solutions. So the data is already there with
Yeah.
a different mechanism. There's no sense in
Mhm.
Yeah.
sending it over again.
And there's intelligence built into there too. So if he's drilling into it and he picks the wrong VMDK, it's going to be grayed out. It's not going to allow
Right,
you to
'cause the
do the
signatures
wrong
don't
thing.
match.
Yeah.
Okay, so.
Even simpler, sizes don't match.
Mm.
Yeah.
Yeah.
And the swap point that you missed earlier, it's here as well. Let me go back to, we wanted to talk about cloning.
Yep.
So, let me go back to this cloning one. So cloning, basically you all know that cloning a VM is something that you can all do, right? You can go to vCenter, clone the VM, you're done, right? We've seen cases where people, basically our customers came back to us and said, I have two challenges. One, I'm trying to make backups on my production side and my backup windows never finish. I can't cope with them. And second, I don't want to do these backups in my production side at all. I actually want to do them in the DR side. And guess what, Zerto, you already have the data in the DR side to control it. So we want to be able to use what you already have with the point-in-time capabilities in order to have a copy of this application that we can expose either to a backup agent or to whatever backup solution we have, or that we can use it for to just create another copy of the application for dev and test, or retain a point in time for a longer period. There are, numerous use cases where you could use it. What we basically allow you to do is go to the application and make an offsite clone. And the offsite clone is extremely simple. Basically, ask you at which point in time do you want this clone to be created, because we already have the journals, right? So we can create this clone on a historical point in time that we anyway have. We can select its target. Here we are in VCD, so obviously the customer cannot select the target. He will get the clone within his org VDC. But I want the point in time clone, and now I'm going to have a full copy of this application sitting there and in a powered off state, either keeping this point in time as for a longer period or integrating with your backup solution of choice and offload it to tape. We have cases where people are actually doing these clones into deduped backend data store. Right? So now they can have multiple points in time returned for a longer period, and they are space efficient by the backend. Okay, so that's a very cool capability that we have there. In terms of keeping things efficient, let me any questions on the cloning?
Okay. Cloned.
Okay. Another thing that we support, and okay, the response time from the GUI is slow, so let me do it without the GUI. Another thing that we support is a thin-to-thick replication. And actually, I must say, the first tech field day that I've been at, we've been asked the very same question: can you replicate thick to thin at the DR site? And at the time, we couldn't, right? So we got this point where we actually encountered this question, and guess what? A year after we're here, we can replicate thick to thin, and we can actually replicate thin to thick as well. So you can go in either direction you want. Again, the idea is space efficiency, right? Being able to balance between performance and how much resources I'm willing to give to my application. Storage tiering. I think that I demoed it through my demo when I created the VPG. Basically, you can tier your DR, right? You can decide that your DR is going to use the same tier of storage or a lower tier of storage. The journals can go to a lower tier of storage. You can really mix and match your needs, again, to allow you to be efficient and cost efficient and balance the performance and the cost of your DR.